Before the Big Bang, what was there? It's a question that echoes in the quietest corners of our minds, a fundamental human curiosity that drives us to look up at the night sky and wonder not just what's out there, but what came before all of it. We trace the cosmic story backward, through billions of years of galactic evolution, past the formation of the first stars, all the way to a single explosive moment of creation. But our imagination insists on taking one more step, into the darkness that precedes the dawn. The simplest and perhaps most profound answer is nothing. But not the nothing you think of when a room is empty. That's a common misconception. An empty room is still something. It's a volume of space filled with air, bathed in ambient light, governed by the familiar laws of physics. It exists within a framework of time where you can ask what was in the room a moment ago and what will be there a moment from now. The nothing before the universe was a deeper kind of nothing, an absence so complete it challenges our language and our intuition. No space, not a vacuum, but the absolute lack of dimension, of here or there. No time, not a frozen moment, but the non-existence of duration, of now or then, and therefore, no before. Imagine pressing reality's power button to off, not just the matter and energy, but the very operating system they run on. When time itself is off, the concept of before doesn't exist. It's a category error. So asking what happened before the Big Bang is like asking what's north of the North Pole. You can keep pointing, but you've run out of north. The map of space-time just ends, or more accurately, it begins. But here's the twist, a profound, mind-bending twist that comes from our deepest understanding of reality. Physics whispers that even this profound nothing is loud. In quantum theory, the emptiest possible state, the quantum vacuum, still flickers with possibility. This isn't philosophical poetry, it's a consequence of the Heisenberg uncertainty principle. The principle states that you can't simultaneously know certain pairs of properties with perfect accuracy. For example, the more precisely you know a particle's position, the less you know about its momentum. This rule also applies to energy and time. Over incredibly short time scales, the amount of energy in any given point in space can fluctuate wildly. Tiny fluctuations. These energy spikes can manifest as pairs of particles and antiparticles that flash into existence before immediately annihilating each other. Virtual this, virtual that. They are a constant, seething foam of transient existence, borrowing energy from the void for a fleeting moment. These are not particles we can hold. They are just the rules of quantum mechanics itching to create. A constant hum of potential in the silence. Some ideas, most notably those proposed by physicists like Lawrence Krauss, suggest the universe could bloom from that quantum nothing, a universe from nothing. Not out of magic, but from a fundamental instability. The total energy of our universe, when you balance the positive energy of matter and radiation against the negative energy of gravity, might be exactly zero. If the universe is a zero-sum game, then creating it from nothing costs nothing. It's the ultimate free lunch. The quantum vacuum, in this view, is a metastable state, like a pencil balanced perfectly on its tip, a state of perfect silence that can't stay silent. Any quantum jitter, any tiny fluctuation, is enough to break the symmetry. Tip. And in that tipping, a quantum fluctuation doesn't just vanish. Instead, it triggers a runaway process. This is the theory of cosmic inflation. The idea is that in the first fraction of a second, the universe underwent a period of exponential expansion. A tiny patch of space, smaller than a proton, inflated to macroscopic size almost instantaneously, smoothing out the fabric of space-time and seeding the structures we see today. This rapid expansion, this hyper-accelerated unfolding of space itself, is the bang. But others say, nothing is a trick word. This is a crucial counter-argument. The quantum vacuum, with its simmering fields and physical laws, is not true nothingness. It's a complex, structured something. It has properties. It has rules. Absolute nothing, the philosophical concept of non-being, is a far stranger beast. No laws of physics, no math, no potential, no quantum fields, no possibility of possibility. This kind of nothing might be impossible to even think about, because thinking itself already uses rules, logic, causality. The very act of forming the question, why is there something rather than nothing, presupposes a framework of cause and effect that true nothingness would not contain. And this leads to another profound idea. Maybe the rules were always there, timeless, eternal. Not existing time, but existing as a foundation a sort of Platonic realm of mathematical and physical law that is the precondition for any universe to exist at all. In this view, the universe didn't come from nothing, it came from the timeless potential encoded in these laws. And if these laws can spawn one universe, why not more? This is where we brush against the speculative edges of cosmology, with hypotheses of a multiverse. Perhaps our universe is just one bubble in a vast cosmic foam, where big bangs are constantly occurring, each one a quantum fluctuation that successfully inflated into a new cosmos. Each bubble could have slightly different laws, different fundamental constants. We simply find ourselves in one that has the right conditions for life to emerge and ask these questions. These are extraordinary ideas, but are there any observational clues? The closest we can get to seeing the beginning is the cosmic microwave background, the afterglow of the Big Bang. Scientists scrutinize its patterns for faint imprints from that inflationary era, potential evidence of quantum fluctuations stretched across the sky, or even hints of collisions with other bubble universes. So far, the evidence is inconclusive, tantalizing but not definitive. Our view is limited. We are inside the painting, trying to understand the canvas. So what did nothing look like? It didn't. There was no look because there was no light to see and no space for light to travel in. There was no where for looking and no when for waiting. There was just the raw possibility, the latent set of rules that could, under the right circumstances, become space, time, and eventually us. When the Big Bang happened, time began ticking forward from zero, and questions like before lost their handles, becoming artifacts of a language built for a world that has a past. And that's the mystery I love, the deep, unresolved beauty at the heart of this question. It forces us to confront the limits of our own understanding. It's the idea that nothing isn't empty. It's the canvas that appears with the painting, the stage that materializes with the play, the rules that emerge with the game. If that bends your brain, good, let it. These are not settled facts, but frontiers of human thought. They are the open questions that keep science vibrant and philosophy relevant. Stare into that word, nothing, and see the different layers of its meaning. The empty room, the quantum vacuum, the absolute void. Because sometimes the deepest answers start where our language breaks, where our familiar concepts fail us, and the universe begins precisely at that point where before ends.